All right, let's try some circular motion problems with outer space. All right, so we got a new planet was just discovered orbiting a star. The planet orbits a star once every 150 days. If the mass of the star is 4 times 10 to the 30th kilograms, determine the radius of the orbit of the unknown planet. All right, so can you figure out what the radius of the orbit of this unknown planet is? All right, so give it your best shot and see what you can do. There's the answer. Did you get it? You didn't, or did you? I can't hear you. You gotta speak louder. All right, well, let's kind of walk you through this. So first things first, if you did not get that answer, then I am super certain you were like, oh, if there's one thing I could do to help me be successful, I'm sure it's to list out my givens. So let's list out the givens and see what we get. If the computer ever, there we go. Here's my givens over here. So you have a period of 150 days, but you don't want it in days, you want that to be in seconds. So do the math, do the conversions to get days into seconds. There happen to be that many seconds in 150 days. You're also given the mass of the planet. So list that out. Okay, so those are pretty much your givens. You might be like, oh my gosh, I wasn't given enough information. But then I'm certain you said, I'm going to draw me a force diagram. That's what I do. That's how I roll. All right, so let's see what that looks like. All right, well, it's pretty simple. I mean, this is what I did here. I just basically said, look, force diagram, boop, force of gravity. It's a thing. All right, so there's my force diagram. But now I got force diagram. What can I draw? That's right, net force equation. Sweet. So net force equation should look like this. If I can get my computer to stop hating me. Oh yeah, see, always start with the bread and butter. Sigma F of C equals MAC, and then you ask yourself, well, what are my forces? Only force is the force of gravity. So force of gravity equals mass times centripetal acceleration. I replace centripetal acceleration with this. Would you go away? Just click somewhere else. I see the t squared with this guy because I was given the period in this problem. So since I was given the period, I wanted to actually use the equation for a period with the 4 pi squared r over t squared instead of the maybe v squared over r. All right, so now that I know this, I can start subbing in other stuff. I know an equation for gravity. Now, since I was given the mass of the star, I'm probably going to need to use universal gravitation. So check this out. All right, universal gravitation states Fg equals m or gm m over r squared. So now that I have this, I see that the mass of the planet itself is unknown and irrelevant, quite frankly. So I can make that go away. I can just cancel out the m's. And then it's a matter of doing some algebraic manipulation. So there is another step that I took. And here, I'll just get this on my way. I'm tired of you. Go away. I don't like you. Go away, go away, go away, go away. There's my answer. So what I did was I subbed everything in, and I said, well, I've got an r squared here and an r squared here. So what I did was I multiplied both sides by r, so this guy goes away, and this becomes r cubed. And so now you can multiply this times that times this. Don't forget that it's squared. Divided by 4, divided by pi squared. And then you got to take the cube root. All right, so just make sure you take the cube root of that, and you will get your radius. Exciting stuff, yes. All right, so again, never fear if you don't have the mass of something. Mass in physics likes to cancel out a lot. All right, so don't freak out. Also, you got universal gravitation versus regular gravitation, because we did not know the gravitational field strength at this location. Now you can solve that because the gravitational field strength is actually just this quantity right here, because it's little m times little g, and so there's your little m. This stuff here is your little g. So if you were ever asked to solve for just the gravitational field strength at location, you would just do g, which is 6.67 times 10 to the 11th, times the mass of the object creating the gravitational field divided by the radius at which you're calculating it squared. All right, so Hopefully that helped. Hopefully you got it right. If you didn't, hopefully you figured out what went wrong, and we'll be good to go for our next assessment in class. So enjoy more physics.